According to 310.15b16, you'll use the higher ampacity when dealing with circuits that have sections in different temperature environments. The rule allows you to extend the use of the higher ampacity beyond the transition point for a specific distance. This distance is either 3.0 meters, which is approximately 10 feet, or 10% of the circuit length calculated at the higher ampacity, whichever of these two values is smaller. Let's illustrate this with an example. Suppose you have a circuit where 5 feet of the run is in an area with an elevated temperature, and the remaining 100 feet is in an area with a normal temperature. The question is whether you should use the total circuit length of 105 feet, or just the 100 feet section at normal temperature to calculate the 10% value mentioned in the rule. The key is the phase length figured at the higher ampacity. This means you only consider the portion of the circuit where the higher ampacity applies when calculating that 10%. In this case, the higher ampacity is associated with the normal temperature section, which is 100 feet. Therefore, you would use 100 feet to calculate the 10%. 10% of 100 feet is 10 feet. This means you can use the higher ampacity for an additional 10 feet beyond the point where the circuit transitions from the higher temperature environment to the normal temperature environment, provided that doesn't exceed the actual length of the run at the higher ampacity. Understanding this rule is crucial for ensuring that electrical installations comply with the NEC and maintain safety. Remember to always refer to the latest edition of the NEC for the most up-to-date information and consult with a qualified electrician for specific applications.